Hello, my name is Pablo Bechtel and today I'm gonna show you how to process the VASP output with Matlab. More precisely, I will show you how to process the density of states with programs I have developed in Matlab. The main idea behind these programs is to be able to extract all the information of the density of state analysis and generate plots with publication quality, in a simple way and without the need of programming skills. If you consider that these programs can be useful for you or your group, you can contact me through this email. I am delivering face-to-face courses which include access to the programs and the tailor of them to meet your needs. Okay, to start seeing how the program works, let's open Matlab. This is Matlab main screen. Here I have developed a function named SOS containing instructions about how to use each program. So the first thing we are going to do here is to type SOS and hit enter. And as we can see, this pop-up menu details all the programs available to process the density of a state. Let's start with the first program, which automatically plots the DOS and PDOS. As we can see, here it says the first line says what's the program do, and after that we have how to use the program. It says that this program needs that the file DOSCAR exists in the current folder. So the first thing to do is navigate and locate the DOSCAR file where we want to plot. And now to execute the program we simply type total DOS, total underscore DOS, and this, well, here it says that the program is busy and in a couple of seconds will generate these three plots, one with the projected density of states, one with the total density of states, and a combination of the two previous plots. As we can see, the program automatically plots the axis labels and plots each atom with a different color. For example, atom number 1 is plotted in red. The numeration of the atoms is the same numeration that's in the postcard file. You also have the possibility to hide curves. For example, if you don't want to see the atom number 1, you can hide it. Also, you have the possibility to change the curve colors and type simply with a double click. We can change the color of the curve. For example, let's put it in. And we can change, for example, for an variable. What else? You can inspect the peak location. Basically, you can do all the editing with Matlab and leave the figure ready for publication. Also, you have the possibility to compare different plots in a simple way. You can copy one curve from one plot. Let's close this. You have the possibility to, for example, select one curve from one plot. Here you can copy and paste in a different plot. Even if the scales are different, Matlab automatically adjusts the curve to the new axis. Okay, let's close this. And we are now again at the Matlab command window. Let's type SOS again and select the second program. As it says, this program extracts the data from the DOS card and plots the projection of the density of states in atom and state, S, P and D. You have different possibilities to plot the density of state of a specific atom and a specific state, for example here, or you can plot the specific state for all the atoms if you select 0 as the first factor, or you can even choose to plot a particular state of a particular element. For example, now we are going to plot the projected density of states of the atom 1 and the level S and P. We hit enter and automatically the program plots the desired density of states. Once again, here we have all the possibilities to edit the plots that we already discussed for the previous program. The next program on the list allows us to zoom over all the density of states present in the graph. So, for example, if you have here and we want to zoom over all the density of states here present in the graph, here we have all the projected density of states. The zoom, it's supposed that will be the same as the total density of states. So we simply hit sum_DOS and this generates a new plot with the sum of all the curves here. We can compare this curve with the total density of states and we see that are basically the same. We can check the peak here and here, and we can see that both plots are the same. For instance, you only want to zoom over a couple of atoms, so in that case you have to remove the rest of the curves and return to the command window, hit sum_DOS and this generates another plots with the sum of the atom 1 and atom 2 curves. The next program on the list allows us to integrate the density of states present in the current graph up to the Fermi level, so you can find the numbers of electrons or even the magnetic moment of the system. For example, if we consider this graph where we have plots the total density of states and want to integrate that curves up to the Fermi level, we simply type integrate _DOS and here it displays, in this case is the total density of states, so this is the numbers of electrons with spin up, the number of electrons with spin down and the magnetic moment. In the case that the curves selected are corresponding to a particular atom, the results will correspond to the magnetic moment of that atom and the electrons associated with that atom. The next program in the list allows us to save the current figure in JPEG formats. So to use the program, you simply type print_fig and the desired name of the figure, and this will generate will save the figure in the current folder. For example, if you are working with a figure like this, you finish your editing, you can also save the figure with the Matlab menu and choose the dimensions and quality, but sometimes this is time consuming, so this function directly save the actual figure. Let's put some name to the figure, test. Saves the figure with a good quality and the correct dimension for the most common journals. So if we hit this, we can see that in the current folder is create this figure, and now we are going to check the quality of the saved figure. And here we can see the quality of the saved figure by the program. And finally, the last program of this module allows us to export the curves in the graph to an ASCII file. So for example, if you have these curves and we want to export only the atom 1 curves, we can hide the unwanted curves and simply type export underscore data and the desired name. In this case, let's put it data, and as we can see, this will generate an ASCII file here. Now we are going to inspect the ASCII file, and as we can see, it generates the information to reproduce that curves in your program of your preference, and also include the headers for each curve. Well, that's all. Thanks for watching, and if you are interested in the programs, contact me at the email address that appears at the beginning of the video. Bye.